Hello and good morning everyone. My name is Allan James. I'm the founder and CEO of Semefab Limited, a private venture wafer fabrication facility based in Glenrothes in Scotland. I founded the company back in 1987, 37 years ago. The company has grown organically on the same site, and we've been very lucky actually in being able to acquire adjacent premises and facilities to get to the situation today where we have not only 3 wafer fabrication facilities operational, but we have expansion potential on the same site on Eastfield Industrial Estate in Glenrothes. A little bit about the company. I'm going to show actually parts or clips from a Semefab tour video that I made at the beginning of the COVID era so that people could have some understanding of Semefab without actually having to visit site. So there'll be a few clips that will be interspersed during this presentation. Delighted to be able to give a quick talk to the NMI Techworks and also to Benjamin Walden from DCMS. So today Semefab is 3 wafer fabs. The original 4-inch fab is still running, but due to be closed during the 4th quarter this year. 2 additional fabs, 6-inch wafer fabs, one focusing on MEMS and sensor technologies. The other one is MOS bipolar facility for active switching semiconductors, integrated circuits, discrete semiconductors such as JFETs, photodiodes, etc., and also integrated circuits and power switching devices. Today we are 130 people. We're running 3 shifts. 101 hours a week, so we're running from 6:30 in the morning through till 1 p.m. on Friday. We have ambitions to run 24/7 as and when the volume of business allows or affords us that opportunity. The Semefab operates what we call a mixed mode business model, where we are both a foundry, where we provide wafers for customers' own processes, and indeed we've been supplier to some very major organizations such as large semiconductor companies in the USA. But in addition to that, we do develop and produce our own devices. Generally speaking, they are either small signal switching devices or they are MEMS type sensor products where they don't compete with our existing customer interests. Semefab today is quite profitable. In fact, we've got to the point now where our volume is such, about 40,000 wafers this year. Just turned in a record month actually, where the bottom line profit was in double percentage figures, which was very welcome. We're exporting about 80% of our product. Roughly a third of that goes to Europe, a third to USA, and roughly a third to Far East, and a fair proportion of that into China. A few words about technologies. Currently we are developing, as part of our future strategy, a 2-stranded strategy actually, aligned with power semiconductors on the one hand and MEMS sensors on the other. And on the power semiconductor side, we're developing silicon carbide Schottky diodes, 20 amp, 40 amp, at 600 volts, 1200 volts, 1700 volt capability. And alongside those, we're also developing a technology known as trench cluster IGBT, which we believe is going to be a very competitive technology, albeit we'll be running it on 6-inch wafers, which is a disadvantage actually. But we believe the combination of the IGBT and the silicon carbide Schottky together in a single package will be a very welcome device to the power switching market. We have 5 major pressure sensor customers, 2 in Europe and 3 in North America, where the devices are going into a broad range of applications, including industrial and into automotive and also into medical, which was very predominant during the early COVID 2020 timeline for respirators, ventilators, etc. The other types of devices that we produce in the MEMS area are things like gas sensors, gas type, in other words, carbon monoxide, nitrogen dioxide, gas flow based on thermopile technology. NDIR gas sensing is a target market for us for CO2, again using infrared absorption and thermopile sensors and microheaters for broadband blackbody radiation, infrared radiation emitters. Thermopiles also for gesture recognition and energy saving applications in things like laptops and computers. And then in the medical area, we're seeing growing interest in capabilities of MEMS to produce either sensor platforms or point-of-care diagnostic chips. In particular, an Edinburgh-based company that we're dealing with developed a chip that's capable of detecting brain tumours using a technique called FTIR, Fourier Transform Infrared Spectroscopic Analysis. And our chip provides the platform for blood plasma to present an interface for analysis through using different frequencies of infrared radiation. Other types of medical sensors that we produce are blood viscosity sensor. These are for people with needing to have blood thinners, people who've had heart disease or strokes and who need to monitor their blood viscosity essentially, or their INR reading. Breath sensing for people with COPD or long COVID is a technology that we have and that we're developing to assist in not really the diagnosis of the condition, but the efficacy of the treatment for people who perhaps have steroids or prescribe some other form of treatment. One of our customers, an Israeli company, actually have developed a breath sensor for the analysis of the VOCs in breath. Their chip is actually capable of detecting COVID-19 and is a generic platform actually that's capable of being turned to other purposes. Semefab's markets are worldwide. Not only are we geographically well spread, but from an applications and a market base, we're widespread as well. So consumer electronics, things like light sensors, ambient light sensing, JFETs for PIR sensing, thermopiles in fact for temperature sensing. During the 2021 second wave of the COVID, we were required to make 12 million thermopiles for forehead temperature guns, for example. Automotive, obviously with the electrification agenda, electric vehicles, chargers are target markets for our power electronic strategy, motor control, power conversion. Everything basically needs to be running more efficiently in terms of losses, and that's what we're aiming for. And on the MEMS front, we're active in the industrial sector, automotive again, a lot of the pressure sensors and so on go into automotive. Robotics and automation, precision electric gratings, for example, that we make for one customer are used to assist in robotic positioning. Internet of Things and the connected sensor environment, again, energy harvesting. These are all areas that are of interest to us. I think there are a lot of opportunities in the market sectors that we've just described, but in particular there seems to be a trend now of reshoring. I think OEMs in particular are becoming more and more concerned about the supply chain problems that have occurred. You only have to look at the automotive industry for the last few years and the chip shortages to see what can happen. Personally, I think academia and startups represent a good hunting ground essentially for new opportunity. I've been very keen to support startups and academia. One of the ones that we're looking at the moment is a retinal implant chip, which is essentially inserted between the retina and the neural network in the eye, and has been proven in fact to enable people with advanced macular degeneration to have the central vision restored so that they can read again. Electrification agenda, spoke about that. Power semiconductors will play into that. The renewables, area for energy, monitoring batteries in electric vehicles, climate itself and sensing contamination and VOCs in the climate. And we touched on robotics for precision measurement and so on. It's always been a challenge at Semefab to turn a healthy profit in the company. We've managed to do that, and in fact we are on a positive trend. It's all to do with wafer volume, and for essentially a bespoke semiconductor manufacturer, which is essentially what Semefab is, we're not competing in the mainstream with major semiconductor players currently anyway. The volumes tend to be in the few hundreds of wafers to low thousands of wafers for any given opportunity. Obviously they all start quite low, and sometimes it can take quite a few years to get to a nice healthy volume. But that really is a challenge, because it means that we need basically to induct through our new product introduction process. We need to induct a lot of different technologies and processes over any given period of time. The results or consequence of that is that we have a development and a manufacturing engineering team who not only look after the day-to-day processes and issues, but are also charged with developing new products on the same production line. Now that's on the one hand a real benefit, because if you develop a product on a production line, you've got a pretty seamless transition into production. But at the same time, it's a double-edged sword really, because you have the problem of setups, set downs and so on to interfere with the production flow when you're doing your development, and it is a real challenge. Another challenge is foreign competition. Clearly in an international market, we are subject to international competition. It has to be said that the foreign subsidies that are going to wafer fabs elsewhere in the world, and the subsidies that are going in terms of not only capital expenditure but also in terms of things like energy support, can make it very difficult to compete. Back in 2006, Semefab was very fortunate in being awarded a government grant under what was called the Micro Nanotechnology Initiative, that actually enabled us to provide matched funding towards a £13.8 million expansion program at Semefab, which resulted in the 2 additional new wafer fabs, which we can demonstrate have more than paid back the government support that we received then through employee taxation, through salaries, etc. So I believe the time is right for this to happen again. I think our industry does need more proactive support from government, and I believe that we are a good candidate, in fact, to do a repeat of the MNT at some point in the not too distant future. We have expansion potential on site to create an 8-inch facility, which will give us, or future-proof us for probably the next probably 15-20 years. So I think that's everything I wanted to say this afternoon. I would encourage you, if you have time, to look at the full Semefab tour, which is on our website on the home page. You can just click on it. You'll see a narrative there explaining everything as we show you the facility. Thank you for your time. I'll be pleased to answer any questions. If you care to email me, it's allan.james@semefab.com. Thank you.